All right, we're going to be continuing our lesson in scientific notation. This time we're going to be adding and subtracting in scientific notation. Adding and subtracting in scientific notation. Hopefully you got a chance to see the one on multiplying and dividing already. So these rules are a little bit different. So let's start out with a problem that looks like this. Let's say you have something that's 6.89 times 10 to the fourth power. Had that look a little bit better? That's better. Okay. Plus, with a plus sign in the middle. Okay. 9.24 times 10 to the fifth power. All right. There's two ways to do this. All right. There's two ways. I'm going to show you both ways. First way is to simply work it out the way you see it, add them together. For instance, 6.89 times 10 to the fourth means I'm going to simply look at this exponent here of 4 and move my decimal point that's here 4 places to the right. That's 2 places right there, so I need another 2, which means I got to add 2 zeros. So this is going to be 6, 8, 9, with the 2 zeros because I had to go 4 places to the right. The decimal is at the end now, okay? On this one here, I look at this exponent, 5, and I'm going to go over 5 places to the right. So that's 1, 2, and then 3, 4, 5. I know I got to add 3 zeros. So I'm going to add 9, 2, 4 with 3 zeros. Now with this, I simply add these two numbers together and it will give me 9, 9, 2, 9, 1, 2. Okay, that's going to be 992,900. Now, I need to change this back to scientific notation. So I'm simply going to take my decimal point, and go back to a spot where the number will read between 1 and 10, which is right here. And that would be 9.929 times 10 to what power? How many times did I move the decimal point? 5 times. It will be a positive 5 because this number is clearly greater than 1. And this is my answer in scientific notation. Now, on this part here, you can use a calculator or you can simply line them up underneath each other yourself like this: 9, 2, 4, 0, 0, 0, and then 6, 8, 9, 0, 0. And you can see how I got my answer there. All right, this will be a 0, that'll be a 0, that'll be a 9, that will be a 2, carry the 1, and this would be a 9, and that would be a 9. I just wanted you to see how we got this number without a calculator, or you can use a calculator and get that number and then convert it back to scientific notation. All right, I'm going to show you another method with the same question. So let me draw a line all the way across. This is the method I want you to use because obviously working it out like this, if this exponent was very large, like 14, you'd have 12 to 14 zeros going across. You don't really want to have to work with those type of numbers. So let me do the same question and work it out a different way. Now this one requires a little bit of memorization of the rules, but it would serve you better in the long run, regardless of the type of exponents you have. It won't matter. All right, so you can have an exponent of 14 or 89. It won't matter. You'll never have to write out 89 zeros. So let's look at this. This is what I want you to do. First of all, I need you to understand that I cannot add these two terms unless they first have the same exponent. I got to get my exponents to be the same. So watch what I do so I can get them to match. When they match, I can simply add these numbers in the front and everything works out. So you'll see what I'm saying. So what I want to do first is I want this 5 right here to go down 1 to match that 4. All right? So this is what happens. When this goes down 1, I'm going to put -1 right here. When this becomes 10 to the 5th, now 10 to the 4th because I subtracted 1. All right? When this goes down, this has to go up. This decimal point must go up 1 to there. Got it? So when this goes down, that got to go up. And that way the numbers mean the same thing. They mean the exact same thing. So let's write it again. You'll see it. Okay, plus 92.4 times 10 to the 4th power. Okay, that's the same as 9.24 times 10 to the 5th. When you work it out, they're the exact same number. All right, so remember that rule. That's the main rule you got to know. That's mainly it. So watch what I do from there. Now, when my bases and exponents are the same, 10 to the 4th, I can actually take my numbers in the front, 6.89, and the other number, 92.4, and add them together. That's this number here and that number there. I can actually add them together, and then I can go times 10 to the 4th power right here. Okay? When I add these two together, watch what happens. It's going to be 99.29. When you add it together, that's what you get, times 10 to the 4th. Now, that's not the answer because this is not written in scientific notation. Because the first number got to be between 1 and 10. So watch what I have to do. I got to take this decimal point and go back 1. But when I do that, my exponent must go up 1. So it equals the same thing. So now my final answer is 9.929 times 10 to the 5th power. And now these two match. I know that's a lot in there, but it's not that bad once you get past that first point, that first step right there. All right, let's look at another one. All right, let's write this one down. 7.83 times 10 to the 8th power. Put that in parentheses. We're going to subtract this time 11,610,000. All right, I'm using real big numbers. Okay, I want you to see what's going to happen here. Now watch this. That second number, that 11 million number, is not in scientific notation yet. So the first thing we want to do is rewrite this problem so that we can see the second number also in scientific notation. All right, so let's write it like this. So what is this number in scientific notation? What I want to do is take my decimal point and bring it all the way to here and go 1.161 times 10 to what power? The 7th. I've moved my decimal point 7 places this way. All right. Now, are my exponents matching? My exponents are not matching. Okay. Now, it doesn't matter if I make the 7 an 8 or the 8 a 7. It doesn't matter. One way is sometimes easier than another way, but right now, just pick one of them. So now I'm going to pick this one. I want this number here to be a 7. So if I subtract 1 and make that a 7, what happens here? This goes up 1. When one number goes up, one number goes down. If this goes down, that will go up. Okay, so it always have to be the opposite. So let's rewrite this. 78.3 times 10 to the 7th minus 1.161 times 10 to the 7th. Can you see what's going to happen now? Now that both exponents are the same, I can now subtract those beginning numbers in the front. So let's do that. So let me change my color here. Let me do that first. When I'm talking about these two numbers right here, I can subtract those. Why am I saying subtraction? Because there's a subtraction sign right there. So let's do that. I got 78.3 minus 1.161. Put that in parentheses, and then just multiply the power of 10. There you go, times 10 to the 7th power. All right, so now you write this once, by the way. Okay, that's all you gotta do is write this once. All right, so now I can actually subtract these two numbers. Okay, when I do that, I get 77.139 times 10 to the 7th power. Is this written in scientific notation? No, it's not. So what do I have to do? I literally have to take this decimal and go back one. But when I go back one, what happens to this number? It goes up one. Remember, always the opposite. Then when this goes down one, that goes up one. All right, so let's rewrite it. 7.7139 times 10 to the 8th power. All right, that is the answer. All right, look how many steps that is. It's a lot of work, but again, once you get past that first step, you're fine through the rest. Okay, all right, let's try one more. All right, let's look at this. Five, 9, 3, 0, 0, 0 plus 7.89 times 10 to the 6th power. Now, listen, you could just work this out and add the two numbers together. You could do that. Okay, so keep that in mind. That is always an option. Just move this decimal point 6 places to the right, add the appropriate number of zeros, add it to that number, put it back in scientific notation. But I want to show you how to do the other method so that when this exponent becomes 62, that you can still work it out. All right, that's what I'm talking about. But when my exponents are small, I would work it out this way, the regular way. But in this case, I'm going to show you how the other way goes. So let's do it again. Let's do it again. All right, so what I want to do is get this number here in scientific notation. All right, so my decimal is here. Where do we want it? We want it here. All right, good. All right, so here we go. 5.93 times 10 to what power? To the 5th power. I moved it back 5 times. Put that in parentheses. Plus 7.89 times 10 to the 6th power. All right, now, are my exponents matching yet? No, they're not. I got to get them to match. So let's add 1 to, see this 5 right here? I need this 5 to be a 6. So I'm going to add 1 here. If I add a number here, what happens to this one? Does it get bigger also, or does it get smaller? It got to do the opposite. It got to get smaller for the two numbers to match. And the value has to mean the same thing. All right, so let's go ahead. Let's rewrite this to look like this. 0.593 times 10 to the 6th power plus 7.89 times 10 to the 6th power. Now my exponents match. When I get them to match, I can add these two numbers. I'm adding because there's a plus sign in the middle. All right, keep that in mind. All right, so let's do that. Just put that in parentheses. 0.593 plus 7.89, and then on the side just write times 10 to the 6th power. Okay, now that I have that, all I do now is add these two together. When I do that, I get 8.483 times 10 to the 6th power, and that is your answer. Notice this number is already between 1 and 10. I didn't have to move the decimal point again. So this is already written in scientific notation. All right, so keep that in mind. All right, very good job.